The concept of the LMFS, light multifunctional frontline aircraft, is a glimpse of what tactical air power could look like in the next decade: compact, highly networked, affordable to procure and operate, and brutally efficient at the small-scale fighters that will define many future conflicts. This is not a heavy stealth bomber or an air superiority giant. LMFS is a different answer to a different question. How do you drive frontline commanders flexible, low-risk strike and ISR capabilities that can be deployed quickly, sustained easily, and upgraded quickly? Visually, imagine a sleek single-engine or twin-engine platform with a modest frontal area, blended wing body hints for reduced signature, hardpoints that accept both smart munitions and modular mission paths, and a cockpit designed for short sorties and intense situational awarenesses. The airframe trades top-end supersonic dash performance for fuel efficiency, range on station, and low sustainment costs. It is optimized to be everywhere at once rather than to win one-on-one dogfights in peer airspace. The design philosophy drives everything about LMFS: payload flexibility, sense of fusion, low logistics footprint, and easy integration into combined arms networks. From a mission set perspective, LMFS is built to be genuinely multi-role. In one core it can switch between precision ground strike with small guided bombs and air-to-surface missiles, battlefield air interdiction to cut enemy resupply, army reconnaissance relaying high-fidelity ISR to ground units, forward air control marking targets for heavier assets, and electronic warfare or suppression of enemy air defenses when fitted with padded EW sights. The modular weapon payload base, internal wear stealth methods, underwing or full-fledged hardpoints wear capacity is prioritized. Let operators tailor loadouts to risk levels and mission priorities. That makes LMFS an ideal workhorse for contested littorals, expeditionary operations, and persistent prisoners missions. Avionics and sensors where LMFS truly comes alive. Rather than picking a single massive radar, LMFS emphasizes distributed sensing, AESA miniature radars, IRST, low sensors with automatic target recognition, passive RF detection arrays, and data link arrays that let the jet see through the sensors of other platforms, monitor human. Sensor fusion and a lightweight AI assistant drive the pilot or remote operator an immediate, prioritized tactical picture, threats highlighted, engagement windows calculated, and recommended maneuvers suggested. The threats pilot workload and shortens the sensor-to-shooter timeline dramatically. In contested electronic environments, the LMFS can operate semi-autonomously, executing pre-planned profiles IF data links degrade, and reconciling mission data on return. Propulsion choice reflect operational priorities. Many LMFS concepts favor efficient, modern turbofan or high bypasses turbofan engines with IR signature mitigation meshes, balancing cruise economy and sprint speed. Short takeoff landing capability is often emphasized so these jets can operate from dispersed, austere fields or roadways, improving survivability by complicating enemy targeting. Reduced logistical needs, commonality of parts, straightforward maintenance, and a small ground crew make it possible to field squadrons quickly and keep sortie rates high. Survivability is achieved by a combination of low observability features, electronic self-protection, and distributive deployment rather than through heavy armor or redundant systems. In other words, LMFS aims to avoid threats rather than suck them. Internal weapon base for stealthier streaks, expendables and towed decoys, advanced chaff, flare dispensers, and aggressive EW paths help it survive in environments short of full peer-on-peer conflict. When the threat environment goes truly high-end, LMFS is designed to operate under the umbrella of long-range platforms, acting as the forward edge of a layered force rather than a solo penetrator. Operationally, LMFS changes how air assets are used. Because it is cheaper and easier to operate than a high-end fighter, commanders can assign it to tasks previously denied to heavier assets, persistent overwatch of supply corridors, rapid strike packages against dispersed targets, and scalable air support for special forces. Its economics make attrition less crippling, losing an LMFS is regrettable, but not necessarily campaign ending. That affordability openness that are two doctrine changes, more distributed airpower, more risk-taking at tactical levels, and a higher tempo of operations. Export and industrial implications are notable. LMFS is attractive to nations that want modern air capability without the price tag and support burden of fifth-generation fighters. IF produced with exportable subsystems and modular interface, LMFS could find global markets among countries modernizing their tactical air forces. For manufacturers, LMFS platforms are tested for modular avionics, AI-guided systems, and fuel sustainment models, technologies that then feed back into higher-end programs. No concept is without trade-offs. LMFS sacrifices maximum air superiority capability and zero power of heavy fighters. In a head-to-head with top-tier stealth fighters it would be vulnerable. Ethical and legal questions around autonomy and lethal decision-making are sharper here because LMFS missions often border on autonomous strike roles, robust human-in-the-loop safeguards, transparent rules of engagement, and international frameworks will be essential. Finally, doctrine and training must change. Operating a fleet of LMFS requires new maintenance practices, new mission planning tools, and a minute shift toward distributed operations. In short, the LMFS idea is neither a replacement for high-end fighters nor a marginal add-on. It is a complementary layer that makes air power more resilient, affordable, and adaptable. IF engineered well and integrated thoughtfully, light multifunctional frontline aircraft can keep frontline commanders better informed, better armed, and able to exert continuous pressure in ways that the big, expensive platforms simply cannot match every day. The future battlefield will reward systems that are networked, upgradable, and maintainable. LMFS checks those boxes and therefore deserves a central place in modern force design.